18 days until SB2 is needed to be completed. Again, if you are keeping up to date with kind of the pace that I've been setting for you, by the end of this week, you should be able to have completed lessons 10, 11, 14, 8, 12, and 15. Okay? Also, friendly reminder, this Friday, 4 days, engine fundamentals needs to be completed by. I am in class on Friday. I will be showing you how to turn that certificate and transcript in. Okay? So that's kind of fun. Yes?
I couldn't figure out how to get the certificate.
Yeah, I'll show you how to do that on Friday. So if you have this done by Friday, you can follow along with me in class, and we can all turn it in together all at once, which is kind of fun. So that way you'll meet that deadline. All right? So we're moving with that. If you have not yet turned in your safety agreement, which there are a few students that still need to get that taken care of, please note that you will not be allowed to go in the shop next week, Monday, when we start getting into lab activity until I get that in my hands, okay? If you need an additional copy of the safety agreement, I got them right over here, okay? Magneted, that's not right. Magnetized to my whiteboard, so just grab one on the way out as you need it, okay? I'll probably be sending out an email or something along those lines later this week to those students that have not yet handed it in, or at least I don't have a record of it being handed in, okay? So there's that. Is there anything else crazy? Homework week this week, so we're out here at 8:44. Okay.
Homeroom all week.
Homeroom all week, every day this week. Friday is a special schedule because we got a pep rally, so I don't even know what that looks like yet. I gotta take a look at my emails. Okay, today what we're gonna end up doing is we're gonna be going through your notes, or going through some more notes. This time we're gonna be focusing on the lubrication systems. Okay, so just kind of a recap of the journey that you've been on so far this school year. Okay, we started out with auto shop safety, right? That kind of hooks you into SB2. We talked about kind of some specific things maybe that you might see, some common sense review. We then stepped off out into identifying vehicles, right? Need to know what car you're working on, what kind of engine it is, and all that sort of stuff, just due to the fact that there's going to be some specific things about that vehicle that probably is true for that vehicle only, okay? Then we went in and we actually started talking about engine fundamentals, right? Hey, how does an engine actually function on a basic level? The different parts and components, configurations. We got into torque wrenches as a tool. Very important tool that you need to know and comprehend what's happening with that tool, how it functions, and how to use it. This week, again, getting into a little bit more deeper. Now we're going to specifically focus in on lubrication system, which is our oiling system in the engine. Later this week, we're going to get into the actual names of the tools, their functions. So we got a whole thing there, and then we'll also get into looking up service information on our computers. So by the end of this week, you'll be completely set up for next week, Monday, to knowing everything, all right? Okay, just like we do with everything else, when you're taking notes, notebooks need to get out. Opening up to a blank sheet of paper in the notebook. Scoot this off to the side just a hair. The topic, engine lubrication systems. So we're going to write that up in the upper right hand corner. So, lube system. Oh. Write your name. And today's date, which I believe is what, the 23rd?
Yes.
Yeah. All right. All right, here's the ASC standards. So you as a student will be able to identify lubrication and cooling system components and configurations. We're going to be mostly focusing on the lubrication side of this standard. We'll get into cooling systems after we get through lubrication systems. You as a student will be able to perform an engine oil and filter change, right? That's what our end goal is going to be. Get you out in the shop, be able to change the oil and filter on a vehicle. You'll be able to use the proper fluid type per the manufacturer specification, right? You need to know what kind of oil you're going to use. Not all oil is made the same. There are maintenance reset reminder lights. They're on most modern day vehicles. I don't know a vehicle that doesn't have one nowadays. So you need to know how to reset that as part of your oil and filter change. And this one's got a little asterisk next to it because in the past, I would like you to perform an oil pressure test. Unfortunately, with the vehicles we have out in the shop, that is exceedingly difficult to do within the time frame that we have at school. So we'll probably do more of a talk through on how to perform an oil pressure test more than actually allowing you to do it. Okay, but that can be a very, very important diagnostic skill that you can perform on your engine. All right, so what I need you to do now is kind of, at least for the top two, kind of come in here and create an essential question that you're going to ask right up here in your notes that you might have immediately. Okay, remember who, what, why, when, where, how. Something along those lines regarding what we're going to be talking and discussing. And again, everyone's going to come up with a different question, totally valid, okay? Don't think you have to ask a perfect question, because there isn't a perfect question. Lots of questions. I always like to start out with the oil change lab as like the first thing we do in the shop because, and you'll hear me say this again, if there's anything that most people probably have done on their vehicle, maybe, it's an oil change. So there's probably experience that you've already had with this type of stuff, or at least you know you should change your oil. Maybe you don't necessarily know how or what's going on, which is totally fine. But most people understand that that's a maintenance item. They need to change the oil. Yeah.
What happens when there's old oil in the system?
Oh, I'll show you pictures.
Okay.
Yeah, you're gonna look at it and go, oh, I probably should change my oil more often than I actually do. Fun story about me, when I was student teaching many years ago, up in Kakana, we actually had an old engine that we pulled out of a van. And the engine was run for many miles and it did not get oil changes very frequently. As we were tearing the engine apart, you know those rod bearings that hold the crankshaft in place, right? We pulled the crankshaft out of the engine, and the smell is something I cannot describe to you, okay? But it is a smell that I can still smell today if I think about it, because it is very unique, and it's basically metal on metal grinding with the smell of like old motor oil, okay? The bearings were shot, the crankshaft was shot. It was not pleasant. And it's unfortunate because that's a very easy thing to not have happen to your engine. If you were to spend $50 on standard maintenance stuff, now you're spending thousands of dollars to replace parts that you shouldn't need to, which is kind of fun, okay? Okay, hopefully you guys got your question down. Again, here I've got kind of a little diagram with the various different parts and components. When you are drawing this, again, don't feel like you gotta get like super crazy detailed on it, okay? Right? Right here in gray is our engine block. You can see the individual cylinders here, so it's an inline 4-cylinder. I'm not worried about the engine block, I'm worried about all these components and how they're actually bolted onto the engine block and their location, right? probably the most obvious thing here is number 5, which is our oil pan. Okay? That oil pan's down at the bottom. It gets bolted on the underside of our engine block, and in between the engine block and the oil pan is our oil pan gasket. Okay, it's a seal to help prevent oil leaks. Just like how we have a front main seal here and a rear main seal to help keep the oil in, we need a gasket between the engine block and the oil pan to make sure we don't have oil leaks. Okay, so that's kind of the first thing. It's the largest part of our lubrication system. Next, we're going to have an oil pan drain plug right down here in the bottom of our oil pan. Oops, I got to go back. When we do oil service on any vehicle, we have to take that bolt out, and all the oil that's stored in the oil pan is drained out of the system. Okay? So we don't actually have to take things apart, we just got to loosen up one bolt. Kind of nice. In order for the engine to pick up that oil from that pan, right, I need an oil pickup tube right here. Okay, this sits in the bottom of the pan, and as the engine is running, this is like a straw that's sucking up the oil, right? And it's circulating it around in the engine block and the cylinder head. The part that's actually allowing that suction to occur is our oil pump, which is going to be number 1 right here in purple. That's our oil pump. What you're going to notice with today's presentation and probably the next couple days presentation is that I'm going to kind of compare our lubrication system with our cardiovascular system in our body, right? We got a heart, we got veins, okay? Our heart is a pump that pumps blood through our entire body, okay? Guess what the oil pump does? It's the heart of our lubrication system. It pumps the oil through our engine block and circulates the lubricant. And then over here, all these components is basically how we take our oil filter and we're able to put it in through an oil filter holder and then into an oil cooler. Right? That gets bolted on the engine, so as we're circulating this lubricant through our engine, we first pass it through the filter, kind of like your kidneys, to filter out any kind of debris or things we don't want getting trapped in our engine block. And then finally we have 7, this little tiny gizmo, that is our oil pressure sensor. So it's an electronic device that monitors our oil pressure, kind of like how sometimes you go into the doctor, they put that big cuff on you, right, and they pump it up because they're checking blood pressure. That's what that is right there. It's checking oil pressure. Too high of oil pressure or too low oil pressure indicates a fault in the system. Right, and that usually will set off the light on the dash or will cause the engine not to run at all. Okay. So a lot of various different parts there, 9 of them. Some of them might be familiar, so some of them might be new. I do want to put a little asterisk on this. Again, as a teacher, I'm trying to find the most generic setup that you would find on most engines. This is not how every engine is configured. Okay? There are some differences where you might have some additional parts that I'm not including here. And you might have some engines that don't have these parts, okay? But again, my goal is to say, okay, 90% of stuff out there in the world, this is probably at least what you're gonna find, okay? So don't go home and be like, I know every single part of every single oil system. You don't, okay? You just know the fundamentals here, the basics. In this presentation we're going to go through, we're going to talk about each one of these more in depth, how that it's all linked together and how it works in total in a system and what that system is designed to do. Okay. All right, hopefully that was a good enough amount of time to draw a picture out. All right. We've got our automotive abbreviations or acronyms. SAE, which is different than ASE, kind of confusing. SAE stands for the Society of Automotive Engineers. All right. Similar to the ASME, American Society of Mechanical Engineers. Okay, this is just a different cult that engineers join. Okay, they do a lot of things in the automotive world, but they're essentially setting standards that everyone follows. Then you got the API, the American Petroleum Institute. Again, another organization that sets standards so that way, regardless of what motor oil you purchase, it uses similar vocabulary and terms so that way the consumer can compare one oil to another and understand the differences between the two. And then we got PCV, positive crankcase ventilation. This is going to come up. We're not going to spend a ton of time talking about the PCV valve today. I won't talk briefly about it. We're going to get more into the PCV valve when we talk about our emissions system. Okay, because that's really more of an emission system part. But it interacts with our lubrication system. So that's why I bring it up now. Okay? So SAE, Society of Automotive Engineers, API, American Petroleum Institute, PCV, positive crankcase ventilation. Ready? Boom. Here we go. Number one, what is the purpose of the lubrication system? I always like to start out with what it's supposed to do. Then we can kind of go on, branch off from that. Okay, so the lubrication system is going to force oil to high friction points in the engine to prevent wear. Engine blocks, cylinder heads, valves, pistons, crankshaft, camshaft, connecting rods, right? All of this stuff is made out of metal. Anytime you have metal on metal movements, it's not only going to generate friction, it's going to generate heat. Over time, that friction and heat is going to wear down the metal.
Or weld themselves together.
Or get so hot where it just kind of gets to know each other so well, they don't come apart. Okay? Which is not great for an engine, right? We need things to move around in our engine.
Separate.
Yes. Okay? Again, it's moving, it's doing all these things as a total, as a whole. To help this metal move and obviously not create or generate a lot of friction, what we're going to do is we're going to put a very thin layer of oil in between those metal moving parts to help assist that moving around. Okay? Now, the problem is I've got stuff all over the engine that's moving and rubbing, okay? So I need to create a system that's going to take and get oil to all of these very sensitive parts. It's kind of a little bit of a daunting task. Yeah.
So why is oil mixed in gas for two-stroke?
Because it doesn't have a lubrication system.
That would explain it.
Yeah. So the oil and gas in that case is mixed together so that way parts get lubricated
Just in a different way.
in a different manner. Right. Good question. All right. Number two, besides reducing friction and wear, our lubrication is also going to do some type of heat transfer away from these parts. Now, that is not its main objective. I want to be very upfront. Oil's main objective is not to cool down parts. It is to help lubricate those parts. Okay? But because that oil is going to come in contact with that metal and friction and all that sort of stuff, it's going to do some kind of cooling. You also need to understand that oil is also going to have detergents and cleaners inside of it. So as that oil is being put onto this, it's going to literally clean the inside of our engine and pick up any kind of dirt and debris and deposits that might be present and carry that stuff away. Okay, that is a secondary purpose of our oil. The more lubrication that we have potentially, the less friction we have, right? The easier it is for that engine to run. And if it's easier to run that engine, the more power that we can harvest from it, which means the more efficient that engine becomes, right? It means I need less gas and air to get the same power out of that. That's good, okay? So that by itself is going to increase fuel economy. Now I can go 30 miles per gallon of gasoline instead of 24 miles per gallon. Any kind of shock between moving parts, it helps quiet that as well. But again, that's not its main purpose. It just happens to do that. Oil between the cylinder wall and the piston also does something else. It helps seal up that combustion chamber. Along with the piston rings are really what seals that up, but the oil just acts as an additional kind of liquid to prevent that blow-by gas from occurring between the piston and the cylinder head. Okay, so these are all kind of secondary purposes of why we like our lubrication system, beyond just lubrication. Okay, so I just want to draw your attention to this real quick, right? You don't have to write this down yet, but start thinking, gee, why is it so important to change my oil? Right? Oh, well, yes, I need to lubricate the engine parts, but also all of this stuff as well. Okay? Kind of fun. All right, the main working parts of our lubrication system are, and you've probably already started to write some of this down when we drew the pictures. We've got our oil pan. Okay, what's the purpose of the oil pan? It's a reservoir or a storage area for our motor oil. And this is a tank, essentially, like you have a gas tank, but this tank, oil pan, is going to accumulate all of the oil. The oil pump, again, is the heart of our system, and that's what's going to pick up the oil from that oil pan and circulate it around in the engine, okay? We'll talk about how it does that here later on, okay? But you got to keep in mind, if the oil pump is not running properly, right, oil is not circulating properly. So that can be a very, very big issue. The oil pressure relief valve, which wasn't on your drawing initially, that's going to be a valve that's going to limit the maximum oil pressure. Okay, so if it notices that we've got too high of an oil pressure, this valve is going to open up and basically allow the oil pressure to drop. So that way we don't blow a gasket and cause a major long-term oil leak. Obviously the oil filter, that's used to help filter out and clean the oil by straining out any impurities and very small particles. Okay, if you've ever drank coffee, right, you get your coffee grounds, you put it in a filter, then you run your hot water through it. What's that paper filter doing to your coffee? It's holding the grounds and preventing those grounds from getting into your cup that you're going to consume. All right, same thing here. My oil filter is literally going to pass the oil through it. Any dirt, debris, anything along those lines that's picked up by the oil as it's circulating, right? Because remember, one of the secondary effects of oil is as a detergent and a cleaner. It's going to pick up all that stuff in the engine. Okay, we got to make sure that it gets filtered out before recirculating it around. Okay, so the oil's passing through that to capture all those particles. Oil galleries, as we talked about last week with our engine fundamentals, is the passageways through the engine block and the cylinder head that the oil is going to pass through. It is the arteries and the veins of our lubrication system. Okay, this is how we get the oil from the oil pan through every single part of our engine. Okay. So we got a lot of different stuff here. All right, moving on. Here's just a picture. Again, this blue part component right there is what? What is this? Crankshaft, okay? Anybody remember what this is called? Yep, it's the snout, because it's sticking out the front. What's attached to the snout of the crankshaft? Anybody? No? That's our harmonic balancer or vibration damper. Okay, there you go. So, anything in orange here, you can see down here, here's my oil pan, right down here. Let me get my marker out. Okay, here's my oil pan. Okay, you can kind of see it kind of comes in there. All right, so this is where the oil lives. Here's my oil pickup tube. All right, so oil gets basically sucked up into here. Okay, as it's going through here. All right, then it goes through the oil filter. Okay, and it circulates up here. Here's all the oil galleries. So you know those rod bearings that are on my crankshaft? Right? Here's the oil. It's coming in here. It's being transported in there, and then it's getting put on the oil, the bearings. So that way, as the crankshaft is spinning, it's basically running on a very thin layer of oil. Okay, but then we also need to pump this stuff up here to our cylinder head, so then that way our valves and all that sort of stuff is lubricated. Eventually what happens is as that oil is being put in here, it's going to drop back down due to gravity all the way down to the bottom of our oil pan. And then it just cycles through. Okay? So that's how that works. Okay, again, here's just kind of a picture of an oil filter, right? Your oil comes in through these holes right here. It gets forced through a paper media, and then it gets collected and then brought back out. Okay, like, and I'm literally talking about paper. We use paper as our, oops, that's wrong, filtration. All right, first question for today. Which of the following holds an extra supply of oil for a lubrication system? Feel free to use your notes, by the way. Take a look back. That's not what I want. There we go. Make sure your fingers are in front of the card. There we go. All right, we get everybody? I think we did. Ooh, baby, nice. 86% got that correct. Oh, hold on. Let me pick on somebody that got the right answer. Let's see, Leo, what do we got? Oil pan, very good. Okay, the oil pan is what's gonna grab that extra supply of oil and as a storage system. Okay, nice. All right, most engine oil is still refined from petroleum or crude oil, just like gasoline and diesel fuel. I'm not going to get into the whole process of how we make motor oil, but basically we bring up oil from the ground, we refine it, okay, and then we package it and we put it in our engines. Okay, that's just kind of how things work. All right, that's where we get it from. So, when you go to Quick Trip and fill up your gas tank, that's also crude oil. It's just refined differently, purified in a different way with different chemicals and stuff along those lines. Same thing with diesel. Okay? So that's the mechanism that we're going to have on that. All right, synthetic engine oil, which is mostly used in most modern day oil vehicles, its base stock is typically manufactured from a man-made substance. Anytime you see the word synthetic, all that means is it's man-made. Okay? It's man-made. Synthetic means man-made. It's not something that we're pulling up from the ground and refining and then putting in our engine. Okay, it's going to be made in a lab. Okay, have you ever heard of synthetic meat? Yeah, it's like, hey, I want a cheeseburger. Cool, I can eat a cow, right? We kill the cow, we harvest it, we process the cow, we make cheeseburgers. Or they're trying to right now make meat, grow it in a lab. Right? Now you don't need to kill a cow, you don't need to raise a cow. Okay, now you can eat that. Problem is it doesn't taste as good as a cow. So we're still a couple years off of that. Hi, morning. Okay, now I'm not asking you guys to drink motor oil because that would be toxic, but it's the same concept, right? You get oil from dead plant life, or we can process it in a lab and come up with different stuff. And the base stock that we can use comes from a lot of different things. More naturally occurring substances, kind of fun. So again, here's kind of the process. Crude oil, we put it in a big, basically still, we heat it up, it separates itself out, and then we go in and we process that further through a chemical plant. And eventually refine it to the point where it can be usable. And then we add different detergents and stuff, again, to make that more applicable to the application. The big thing is, let me go in here, conventional motor oil. Like, this is stuff I don't even think, well, you're going to use, but the molecular structure on here is varied. Okay, it's gonna be different sizes. All right, it's not consistent. Where synthetic oil is a much better product because every molecule in that synthetic oil is the exact same. Okay, now if you think about these circles as like ball bearings, if I've got a piece of metal that's moving this way, right, and it's moving against another piece of metal, I've only got, right, 2 of these ball bearings in contact with that, so that's going to obviously not work if these aren't even touching. Not great. Synthetic oil, because they're all the same size, we have a much larger surface area. It's better at lubricating. Okay, it can move easier. So it's a superior product to be able to use in an engine because of that very reason. Again, I'm not going to get into this, at least right now. Okay, so that's kind of where we get the oil from. We're going to put it in our engine. Oil is going to be forced through small spaces known as bearing clearances. Again, if I were to come and kind of draw this, right? Here's my crankshaft. Here's my crankshaft. Okay, my rod bearing is essentially encapsulating that crankshaft. This is going to be spinning, but the crankshaft is never actually touching the rod bearing. For good reason. I don't want to, because that's going to generate friction and heat. So what we end up doing is we put some oil in here, and that oil molecules are going to be essentially surrounding this crankshaft and rod bearing. And as this spins, it's riding on that, okay? So it allows it to freely spin. The problem with this is the difference between this and this is thousandths of an inch. Like literally the thickness of a human hair. It's extraordinarily thin. Okay? Like 2/1000ths of an inch. You would not probably be able to see that necessarily under just normal eyesight. Okay? We actually have to use a tool over here to measure that clearance. And that clearance can change based off of the application of the engine. I'm not going to get into that right now, but 2/1000ths is probably the starting point. Okay? Now, if I've got brand new oil, if I got brand new oil, it's going to fit in here, no problem. What happens after that oil starts to break down? It's going to get a little chunky, right? It's like leaving milk out on the counter. You do that for long enough, the milk starts getting chunky. You're like, oh, I don't want to eat that. Yeah, same thing with our oil. Now it's harder to get into that bearing clearance. Now you're going to increase your friction. All right, crankshaft, connecting rod, and cam bearings are categorized as a friction or a plain bearing. Important to understand the difference between the two. Okay, we've got a friction bearing. What does a friction bearing mean? It means no moving parts. No moving parts on a friction bearing. It is literally a metal insert. Okay, so you can kind of see here some examples of some friction bearings. Okay, here's a picture of an actual friction bearing right there. Okay, you can see there's a hole right here that the oil comes through. Alright, and then the oil is going to basically be pressurized and squirted out, pressed out all over that bearing. Okay? If, for whatever reason, that crankshaft comes in contact with that rod bearing, right? What we want is this rod bearing to become damaged. That's what it's designed to do, okay? Because this right here is much cheaper to replace than an entire engine block or an entire crankshaft. That's expensive. So I would prefer to just replace that. Cheaper. Not cheap, but cheaper. Okay? So that's kind of the idea behind that. Now, anti-friction bearings, this is your second type of friction, or excuse me, bearing. Alright. That is going to use balls or rollers to reduce friction. Okay, have you ever heard of a ball bearing?
Yes.
What is that? Well, it's literally a pure metal ball that's put in this bearing, and as this bearing turns, or this object is turning, okay, instead of using oil as a lubricant, it uses the rolling force of that ball, or balls, it's more than just one, to be able to rotate that, okay? We do not have anti-friction bearings inside of our engine. Okay, we only have friction bearings in the engine. Typically, anti-friction bearings is probably going to end up being used more for your, like, wheel bearings in our suspension system. So, nothing that we're going to talk about right now. I just need you to understand the difference. We've got friction bearing and we have anti-friction bearings. More often used in the drivetrain or suspension systems. All right. Yeah, there's a whole host of that. We'll get into wheel bearings when we get into that. Kind of fun. All right, oil's viscosity. This is a term that you're going to definitely need to make sure you write down. Viscosity. That is something that we are going to be using terminology-wise, okay? Viscosity is referring to the thickness, fluidity, or resistance to flow. That's what that means, viscosity. Now, if I were to step back for a second and not talk about motor oil, we could talk about some substances that you're probably more familiar with, such as
Water.
agua. Water is a liquid. It flows, as you are well aware, okay? Water has a viscosity. I believe its viscosity rating is 0. Because every other liquid is going to be compared to the viscosity rating of water. Why? Because we're so familiar with water. We use it all the time. We have kind of a general idea of what it is. Okay? Now, let me talk to you about a different liquid that you're probably familiar with.
Maple syrup.
Yeah, it's like Wheel of Fortune up here. Maple syrup. Right? Have you ever poured maple syrup on your pancakes? Let me ask you this. Is it thinner or thicker than water?
Thicker, a lot thicker.
Yeah, okay, it's thicker, which means it pours more slowly than water, okay? How about ketchup, right? You ever get those glass bottles? I'm probably dating myself now. You get ketchup in a glass bottle, you're like trying to get it out,
Nah.
and it's like, come on, what's going on? It's because its viscosity is so much higher, okay? So the concept here is we have various different motor oils and different viscosity ratings of those motor oils, which means some motor oils act more like water and can flow very easily. Some motor oils are much thicker, okay, and they don't flow quite as easily. All right, here's the deal. Again, high viscosity numbers indicate a thick oil. Low viscosity numbers indicate a thin oil. Higher the number, thicker it becomes. Lower the number, the thinner it becomes. Here's kind of a chart to kind of indicate that as a graph. But we'll just kind of give you a couple examples, right? Let's say I have a 0 viscosity rating oil.
Thin.
That's as low as it goes. Is that high or low? It's low, which means it indicates that oil is very thin. Right? That's as thin as it gets. Can't get any thinner. All right, then we could go all the way up to maybe like, let's say 30. That's our viscosity. That's much higher. 30, much thicker. Yeah.
What's standard viscosity for your oil?
10.
Now, what we have is what's called a multi-viscosity oil. I think, is that my next slide? No. We'll get into that here. Nowadays, you're probably seeing 0W20. That's probably more common. 5W30 was like the big king back in the day. Everything was 5W30. Nowadays, we're probably seeing more 0W20. And we'll talk about what happened between why we started switching over to 0W20. All right, remember the SAE? We talked about it at the beginning of the presentation. SAE stands for the Society of Automotive Engineers. They're the organization that basically tells everyone, or they rate the viscosity of all engine oils. Hey, I'm Valvoline. Cool. I'm going to take this oil that I just produced. I'm going to send it off to the SAE. They're going to test it, and then they're going to tell me what the viscosity rating is. Hey, this oil that you just tested, that falls in the category of 5. That's its viscosity rating. Ooh, okay. Right? Hey, I'm Pennzoil. Completely different company. Right? I don't good to know what Valvoline does with their oils. Instead, I'm gonna come in here, I'm gonna make my own oil. I'm gonna send that off to the SAE. Now they're gonna grade that when they come back and say this motor oil is a 10. Right? Oh, as a consumer, which one do I buy? Do I buy Valvoline or do I buy Pennzoil? I don't know. What's the difference between the two? Well, I have this number. This one says it's a 5, this one says it's a 10. I now have a comparison of oils, right, in terms of the viscosity rating, and then I can make an educated decision about what I should put in my car, based purely on that. Okay, now there's other factors as well, but that's just so that way you are aware. We're going between brands here. Yeah?
Why does a dirt bike have thicker oil?
Well, it's going to be 2-stroke, yeah?
No.
Usually 10
No.
2 or 4-stroke?
A dirt bike probably has it. I can't give you a definitive answer.
I think I have 10W30.
Sure.
Most run 10W.
Which isn't super bad. 10W30 is not horrible. We'll probably talk maybe more about what the all that sort of stuff means here in a little bit. Hopefully that answers your question.
Based on how you run?
Yeah.
10W30.
All right, multi-viscosity oil, like we just talked about. This will be the last slide that we'll end up on today because we're out here at 44. Multi-viscosity oil. All this means is that the oil has a fluidity of a thin oil when it's cold and a thick oil when it's hot. It's got multiple personalities. So when it's January in Wisconsin and it's cold out, we want a thinner oil. It flows easier in the cold. But when it gets super hot out, I don't want to get so thin that it kind of doesn't actually cover my bearings. I need it to be thicker. So we kind of build or engineer this oil to be able to do both, which is kind of cool.
How long will that take to figure out?
A while. All right, we'll pick up on number 12 tomorrow. I'm not done talking about this, but we'll get into that later.